Hey class, thanks for tuning in to the 7.3 video. Today we're going to be talking about rational exponents. So as you guys have guessed, before we get started with the rational exponents, I want you to take a minute and work on those 5 review problems, and when you get back we will take a look at our new terms. Alright, so with our rational exponents, what is a rational exponent? Well, for any positive real number b and any integers m and n, as long as it's greater than 1, we have b to the m over n. So that right there is going to be a rational exponent, as long as n is greater than 1. So b to the mn is the same as the nth root of b to the m power. So in this example, m over n is a rational exponent. Now we've said cube root a lot lately, and whenever we say a cube root, that is if a to the third is b, then a is the cube root of b, because a to the third power equals b. Same thing goes for the nth root. When we say the nth root, we're going to be able to fill in any positive integer for n. So a to the nth power equals b, then a is the nth root of b. We'll be working with a lot of exponential equations now, and an exponential equation is an equation in which the variables occur as exponents. So that's easy enough. Alright, now we can come down here and put a little practice into this. So our first key concept is b to the 1/2 power. So whenever we say b to the 1/2 power, it's the same as saying the square root of b. Right? So 16 to the 1/2 power is the same as the square root of 16, which we all know is 4. So let's look at our first example. We've got 81 to the 1/2 power, which is going to be the same as the square root of 81. And the square root of 81 is 9, and that's going to be our final answer. But we can switch from back and forth between radical form and exponential form. Alright, so now we've got 38 in radical form. We want to express it in exponential form. So we're just going to say 38 to the 1/2 power. And that there's going to be our final answer. Now for our next one, it's a little different because we have a 12 and an m. But remember, since we don't have parentheses here, the 1/2 power is only going to stay with the m. So when we rewrite this, it's going to be 12 times the square root of m. And that's going to be our final answer. So I'm going to let you guys try and knock out numbers 4 and 5, and we'll scroll on to our next key concept when you get back. So our next key concept is the nth root. So in the example they give us here, the nth root, if we have a to the nth power, then that equals b, then a is going to be the nth root of b. And so there's two ways to look at that. If an equals b, then this here we have the nth root of b equals a. Alright, so if 2 to the 4th is 16, then 2 is the 4th root of 16. Alright, so if we look at our first example, one thing we can ask ourselves when we're doing it is, well, what they're asking us is, what's the 4th root of 256? So we're saying, what times itself 4 times is going to give us 256? Well, the first way we can do it is we can break it down into multiple factors. So if we got, that's a 4 there. We got 4th root. If we divide 256 by 4, it's going to give us 4 times 64. So that's a good place to start. Then we can break the number 64 down even more. So that's what we'll do here. We'll come on down here. So if we divide 64 by 4 again, then we're still going to have that first 4. And then 64 is going to be 4 times 16. And then we see we can break the 16 down again. And we're going to keep the same 4s that we had before. And 16 divided by 4 is 4 times 4. So if you look there, we've got 1, 2, 3, 4 4s. If we multiplied all this together, we would get our first number, 256. So 4 is going to be the fourth root of 256. So you guys go ahead and see if you can figure out number 2 and number 3. For number 3, we're doing the sixth root of 15,625. So what times itself 6 times can give us that number. And for number 3, we're doing a fourth root. So what times itself 4 times will give us 2,401. Now we've already taken a look at b to the 1/2 power, but what if we have b to the 1 over n power? So we have b to any other number than 2. Well, it's going to be really similar to what we saw with 1/2 power. b to the 1/2 power, like we said, is the square root of b. Well, if you see here, we have 8 to the 1/3 power is just going to be the cube root of 8. Okay, so we're going to take a look at our first example, and what we have here is 1,331. We're saying what is the cube root, because it's to the 1/3 power, of 1,331. And then we're going to break 1,331 down. If we divide that by 11, then we get 11 times 121. And we can divide this 121 by 11 again. And that will give us, we keep our first 11. 11 times 11 is 121. So if we multiplied all of that out, it would be 1,331. So our final answer is going to be 11 is the cube root of 1,331. Okay? And so I'll let you guys work on number 2 and number 3. You're going to be doing the exact same thing there. This time we'll be in this number we'll be looking for the fourth root. We'll be looking for the fourth root in this one as well. So what number times itself 4 times is going to give us those answers? Let's move on to our next key concept is b to a rational exponent when we don't have a 1 in the numerator. So if we look at the example they give us, we have b to the mn. So if we have b to the mn, then our n is going to be the root, and m is going to be what our exponent left over is. Okay, and so this is just another way to re-express that fraction. So if we look at the example they give us, we have 8 to the 2/3 power. So we took the denominator of the fraction, made it the root, and then the top of the fraction became what our exponent is for the cube root of 8. So we know the cube root of 8 is 2 because it is 2 times 2 times 2. If we multiply all that out, we would get 8. And we have all of that squared. So we have 2 squared gives us 4. And so our final answer for that one is 4. Let's take a look at number 1. They ask us to simplify it. So we can rewrite this in radical form, and our 5 is going to be our root. 32 will be inside, and then all of this is going to be to the 2nd power. Okay, so now the first thing we want to do is say, what is the cube root of 32? Well, the cube root of 32 is 2 because it's 2 times 2. So times 2 times 2 times 2. So if we multiplied all of those out, that would give us 32. But we still have all of this to the second power. So we have 2 to the second power, and that is going to give us 4 as our final answer. Okay, so you guys can work on number 2 and number 3, and you can be able to knock those out. Our last key concept is the power property of equality. And so that is just saying if we have 5 to a certain power, if they tell us that it equals 5 to the power of 3, then obviously x has to be 3 in order for those to be equal. And if we have 4 to the nth power and equals 4 to the half power, then we know that n is going to have to be 1/2 in order for those two to be equal. So we're just going to use that concept to solve our missing variable. So if we have 9 to the x power equals 729, well, what's another way we could express 729? Well, I've used my calculator and messed around with the number 729 and found out that 9 to the third power is the same as 729. So if I did 9 cubed, that's going to give us 729. So I'm not changing the equation at all. I'm just rewriting it. So now we have 9 to what power equals 9 to the third. Well, in order for these to be equal, which they are, then x is going to have to be 3. And we'll use the same logic for number 2. First, we want to look for a different way we can re-express this equation, because we want to get, like we had over here, we had the same base, right? So we want to see if we can get the same base with 16 and 8. Well, I know that 16 is, another way to write 16 is 2 to the fourth power. But we can't get rid of the exponents that are already there, so we have 2x minus 1 is still there. Equals, and another way to write 8 is going to be 2 to the third. So if we multiplied 2 to the third, we would get 8. And if we multiplied 2 to the fourth, we would get 16. So now we have two sets of exponents with a base of 2. So we can say that 4x, or 4 times 2x minus 1 has to equal 3 in order for that to be true. So now we can just do our simple algebra and distribute the 4 and get 8x minus 4 equals 3. Subtract, or add 4 to both sides, and we get 8x equals 7, and our final answer is going to be x equals 7 divided by 8, 7/8. Alright, so let's move on to our last example from, number 39, or number 3. Don't worry about doing that one. That one is written wrong. So let's skip that one and go on to number 4. So the population of P of a culture that begins with 40 bacteria and doubles every 8 hours can be modeled by P equals 40 times T to the T divided by 8, where T is time in hours. So they want us to find T if P equals 20,480. So we're just going to substitute in for P and sub for T. So we've got 20,480 equals 40 times 2 to the T over 8. Alright, so the first thing I'm going to want to do here is divide each side by 40. So then we'll be left with 512 equals, 2 to the t divided by 8. And if I divide 5 by 12, we can break it down and keep breaking it down until we get 512 can be re-expressed as the base power of 2 to the 9th. So all I did here was rewrite 512 in a different way, which is 2 to the 9th. So if I did 2 to the 9th, I would get 512. That way we have the same base on both sides. So in order for this to be true, our exponents have to be equal. So we can bump up over here and say that 9 equals t divided by 8. Multiply each side by 8, and we get 72 equals t. So that is going to be our final answer for that one. And I want you guys to go ahead and do number 5. We can talk about that one in class if you have any questions. Alright? See you guys tomorrow.